Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 1 in a session May-June 2021 Paper 1-2. So let's start with the first question. Question number 1, Part A, express the standard form of a quadratic equation in the form 4x plus a whole square plus b. Okay, so 16 we can rewrite 16 as 4x whole square minus 2 times 4x, and 2 times 4 is 8 and 8 times 3 is 24. So times by 3 plus adding 3 square and subtracting 3 square and plus 10. Okay, so this is 4x minus 3 whole square, and this is plus 10 and minus 9. 3 square is 9. This is 4x minus 3 whole square plus 1. This would be equals to 4x plus a whole square plus b. This implies your a value is minus 3 and b value is positive 1. Right. Now moving to part B, it is given that the equation 16x square minus 24x plus 10 equals to k, where k is a constant, has exactly one root. We already found the form of this equation from a part, which is 4x minus 3 whole square plus 1. This would be equals to k, where k is constant, has exactly one root. Find the value of this root. So it has one root when the k value and this b value is same. Let k equals to 1. So when k is equals to 1, we have 4x minus 3 whole square plus 1 equals to 1. Right, so we have 4x minus 3 whole square. This would be 1 minus 1. 4x minus 3 whole square, this would be equals to 0. Taking square roots on both sides, 4x minus 3 would be equals to 0. 4x would be equals to positive 3. And what is x? Which is 3 by 4. So this the value of this root is 3 by 4. Question number 2, part A. The graph of y equals to f of x is transformed to the graph of y equals to 2 times f of x minus 1. Describe fully the two single transformations which have been combined to give the resulting transformation. Right. So we have y equals to f of x. This is the base function. It is transformed to y equals to 2 times f of x. Right, so 2 times f of x, it means we have a vertical stretch by a factor of 2, right? And we have y equals to f of x minus 1. This minus 1 is a horizontal translation, 1 unit to the left. Horizontal translation, 1 unit, to the right, not to the left. So these are the two set of transformation, which is a vertical stretch and a horizontal translation. Now for part B, the curve y equals to sine 2x minus 5x is reflected in y-axis. The first thing, it is reflected in y-axis, right? And then stretched by a factor of 1 by 3 in the x direction. Write down the equation of the transformed curve. So first transformation we have to apply is number 1, reflection in y-axis. Right, so when we have a reflection in y-axis, we have a function y equals to f of minus x. So here we have the function y equals to sine 2 times of minus x minus 5 times of minus x. Y equals to sine is odd function, so we have minus sine 2x and plus 5x, right? Now we have to apply the second transformation, which is stretch. By scale factor of 1/3 in x direction. Okay, so for stretch, what we have to do for x direction stretch, we have to do y. Fy would be equals to f of ax. So a is the value of in x direction a. If y would be equals to f of anything that is inside the bracket is reverse, so a would be the reciprocal of 1/3, which is 3x, right? So we have the equation now. Y is equals to minus sign 2 times x is replaced with 3x plus 5x is replacing with 3x. So y would be equals to minus sign 6x plus 15x. This is the equation of the transformed curve. Question number 3. The equation of a curve is y equals to this. The following points lies on the curve. Non-exact values are rounded to 4 decimal places. Point A, B, C, D and E lie on the curve, right? Part A, find K, giving your answer correct to 4 decimal place. Okay, so since the point A lies on the curve, so it satisfies the curve, we can say. So now y, we have to substitute the point A. The y is the k value. Y is k. This would be equals to 2 minus 3 square root of 2 plus 1 plus 3. So k would be equals to 2 minus 3 is minus 1 square root of 3 plus 3. So k would be equals to 3 minus square root of 3. We have to find the answer up to correct to 4 decimal places, right? 3 minus square root of 3, 1.2679. K is equals to 1.2679, right? Now for part B, find the gradient of AE, A and E, giving your answer correct to 4 decimal place, right? So the gradient of AE formula is y2 minus y1 over x2 minus x1, right? So we have a point A which is 2 and 1.6. A is 2 and 1.2679, and the point E we have is 3. Okay, so for AE, y2 minus y1, so we have 3 minus 1.2679 over x2 minus x1, which is 3 minus 2. 3 minus 2 is just 1. So we have 3 minus answer, which is square root of 3, which is 1.7320, and 5 round to 1, right? 1.7321 up to 4 decimal place. Okay, the gradient of BE, CE and DE rounded to 4 decimal place are this, this and this respectively. Part C, state, giving a reason for your answer, what the values of 4 gradient AE, BE, CE and DE for gradient suggests about the gradient of the curve at point E. So what is a gradient of the curve at point E? The gradient of the curve at point E means we have to find dy over dx at x is equals to E, right? Okay, so what the values of 4 gradients suggest about the gradient of the curve at point E? So we can say that the 4 values of gradients suggest that the gradient of curve at point E approaches to gradient of the curve at point E approaches to 1.7, 1.9, 1.99, 1.999 approaches to 2 as x approaches to 3. So as you can see, all the values x are approaching to 3. A we have 2, 2.9, 2.99, 2.999, and A is already 3. So as x approaches to 3, right. Question number 4. The coefficient of x in the expansion of 4x plus 10 over x whole cube is p, and the coefficient of 1 over x in the expansion of 2x plus k over x cube power 5 is q. Given that p is equals to 6q, find the possible values of k. Okay, let me expand this and find the coefficient of x, which is p. So the first term is 4x whole cube plus 3c1 4x square and 10 over x power 1. So here we will get the coefficient for x. Yes, okay. And 3c2 4x power is 1 and 10 over x whole square. 3c3 4x power would be 0 and 10 over x power is 3. Okay, so this gives me x cube, this gives me x and x square. So we have x, here we have 1 over x, and here we have 1 over x cube. So this term give me x cube. Okay, so we can say that the coefficient of x, which is p, which is equals to 3c1 4 square, and we have 10, right? Because x and x square is cancelled, we will get x, right? Okay, let me simplify. What is 3c1, which is 3 times 4 square times 10, which is 480, right? So the p value is 480. Okay, now the second part, it says the coefficient of 1 over x. Let me expand this. So 2x power 5, 5c1, 2x power is 4, k over x square, its power is 1. So x square and x4, so we will get x square, x power 5 here, x power 2 here, we need 1 over x. Okay, let's expand it further. 5c2, 2x power is 3, and k over x square, its power is 2. Okay, x square would be x4 and x cube, and we have 1 over x4, so we will get 1 over x, yes, plus up to so on. Let me write down coefficient of 1 over x. Coefficient of 1 over x is q here. So what is q? Q would be 5c2 2 cube and k square, because x square is x4, so we have 1 over x4 here. So we have x cube and 1 over x4. So cube and this 4 is cancelled, and we are left with 1 over x. Yes. Okay, let me simplify this. What is 5c2? 5c2 is 10 times 2 cube, and this is 80 and k square, right? So this would be equals to 80 k square. Okay, now the question says given that p would be equals to 6 times of q, we have to find the possible values of k, right? P is equals to 6q. P value is 480, which is equals to 6 times of q value, which is 80 times k square. We have to find the possible values of k. So 80 times 6 is 480, right? Okay, so 480 equals to 480 k square. Dividing by 480 on both sides, we will get 1, right? So from here, k square is equals to 1, and what is k? K would be equals to plus minus k root of 1. So k would be equals to plus minus 1. So these are the two possible values of k, positive 1 and negative 1. Question number 5. The function f is defined by f of x is 2x square plus 3x for x is greater than equals to 0. Part A, find and simplify an expression for f composition f of x. Right, f of x is 2x square plus 3, right? And this is f of 2x square plus 3. This would be equals to 2, and we have 2x square plus 3 whole square plus 3. Now let me simplify. We have 2 is outside, 2 square is 4, and x square is x square is x power 4, 3 square is 9, plus 2ab. So 2 times 3 is 6, and 6 times 2 would be 12. Yes, we have 12x square, and 3 is outside. 2 times 4 is 8, x power 4. 2 times 12 is 24, x power 2. 2 times 9 is 18 plus 3. So 8x power 4 plus 24x square, and 18 plus 3 would be 21. So this is a simplified expression. Now for part B, solve the equation f composition f of x would be equals to 34x square plus 19. So put this equals to this. So 8x4 plus 24x square plus 21 equals to 34x square plus 19. Right, 8x4 plus 24x square minus 34x square plus 21 minus 19 equals to 0. So 8x square minus 10x square, 8x4, sorry. And what is 21 minus 19? Which is 2. Plus 2. This would be equals to 0. So dividing by 2 on both sides. 2 times 4 is 8, 2 times 5 is 10, and 2 times 1 is 2. Right, now let me factorize this. 4 times 1 would be 4, minus 4 minus 1 makes minus 5. Right, 4x4 minus 4x square minus x square plus 1 equals to 0. Taking 4x square common, we are left with x square minus 1. Taking minus 1 common, x square minus 1 equals to 0. 4x square minus 1 is the factor, and x square minus 1 is the factor. Let me put both the factors equals to 0. X square minus 1 equals to 0, and 4x square minus 1 equals to 0. So from here, x square would be equals to 1, and x would be equals to plus minus 1. And here we have 4x square is 1, and x square is 1 by 4. And what is x? The x value would be equals to plus minus 1 by 2. Right, plus minus 1 by 2 and plus minus 1 by 4. Plus minus 1 are the two solutions. Okay, but we have a given domain that x should be greater than or equals to 0. So what are the values of x? So since x is greater than or equals to 0, so the only solution is x is equals to 1 and x is equals to 1 by 2. The positive, we have to consider the positive solutions. Question number 6. Points A and B have coordinates 8, 3 and PQ respectively. The equation of the perpendicular bisector of AB is y equals to minus 2x plus 4. This is equation of perpendicular bisector. Find the values of P and Q. Okay, so for equation of perpendicular bisector, first we have to know that what is the slope of AB. Slope of AB is slope of negative reciprocal of the perpendicular bisector. Negative, it would be plus, and reciprocal is 1 by 2. So this is 1 by 2. We need to find the slope of AB, which is y2 minus y1, q minus 3 over x2 minus x1, p minus 8. Do the cross multiplication. P minus 8 would be equals to 2q minus 2 times 3 would be 6. Okay, so p would be equals to 2q minus 6 plus 8. So p would be equals to 2q plus 2. This is my first equation, right? And for the perpendicular bisector, we need the midpoint of AB, right? So for the midpoint, we can say midpoint of AB, we can say the midpoints are x0 and y0, right? And this would be equals to sum of the x component dividing by 2, which is p plus 8 divides 2, and the y component q plus 3 divides 2. So x0 is p plus 8 by 2 and y0 is q plus 3 by 2, right? And for the equation of perpendicular bisector, if I rewrite equation of perpendicular bisector of AB, right, we can write down this equation as y minus y0 is equals to m into x minus x0, right? Y minus, what is y0? Y0 is q plus 3 over 2 equals to m. Slope is negative reciprocal, which is negative 2, into x minus x0 is p plus 8 dividing by 2. So from here we will get the equation in terms of p and q, right? So let me simplify this. We have y would be equals to minus 2 times x, right, and minus 2 times of p plus 8 over 2 and plus q plus 3 over 2, right? Okay, so if I compare this equation with my given one, which is y equals to minus 2x plus 4, right? So let me compare with y equals to minus 2x plus 4. So y equals to minus 2x, y equals to minus 2x. So it means this term would be equals to 4, right? Okay, so we can say that from here, cancelling the 2. So minus p plus 8 plus q plus 3 by 2, this would be equals to 4, right? Sorry, this is not minus. Minus 2 times minus x, minus times minus makes plus. So this is plus, right? Let me make an equation in terms of p and q. So we can say that multiplying throughout the equation by 2, right? So 2p plus 2 times 8 is 16 plus q plus 3 would be equals to 2 times 4 is 8, right? 2p plus q, this would be equals to 8 minus 3 minus 16, right? So we can say 8 minus 3 minus 16 makes minus 11. So 2p plus q equals to negative 11. So what is q? Q is minus 11 minus 2 times of p. So the p value is 2q plus 2, right? So this is 2q plus 2. So q equals to negative 11 minus 2 times 2 is 4q minus 4. So q plus 4q, this would be equals to minus of 15. Minus 11 minus 4 is minus 15. And we have 5q is equals to negative of 15. And q would be equals to negative of 3. Right, so we got the q value, which is negative 3. So when q is negative 3, what is the p value? So substitute over here, we will get the p. So p would be equals to 2 times of minus 3 plus 2. 2 times minus 3 is minus 6 plus 2, which would be equals to minus 4. So p is minus 4 and q would be equals to negative of 3. Question number 7. The point A has a coordinate 1, 5 and the line L has gradient minus 2 by 3 and passes through A. So the line L passes through A. So first let me write down the equation of line L. we have given the gradient and it passes through A. So y minus y naught equals to gradient minus 2 by 3 into x minus x naught is 1, which is this is the equation of line L. A circle has the center 511 and radius square root of 52. Now let me write down the equation of circle, which is x minus 5 whole square plus y minus 11 whole square. This would be equals to 52, right? Now for part A, show that L is tangent to the circle at point A. So if L is tangent to the circle at point A, the first thing we have to check that is point A lies on the circumference of a circle, right? Point A, which is 1 5, lies on A, lies on circle. So if it lies on the circumference of a circle, so it must satisfy the equation of the circle, which is 1 minus 5 whole square plus 5 minus 11 whole square. Okay, 1 minus 5 whole square is minus 4 whole square, and 5 minus 11 is minus 6 whole square. Okay, 5 minus 11, yes, minus 6. So 4 square is 16 and 6 square would be 36. So what is 16 plus 36? This is 52. So it satisfies, right? So it means the point A lies on the circumference of a circle, right? Okay. So I drew the circle. Its center is 5 and 11. X coordinate is 5. Y coordinate is 11. X coordinates, A lies somewhere over here. X coordinate is 1 and the Y coordinate is 5, right? And if I draw the equation of line L, which is tangent to the circle at point A, we have to prove. So this would be the line L. Okay, so the point A lies on the circle, right? And the second thing, if it is for tangent to the circle, so we can say that L is tangent to the circle. L is tangent to the circle when the gradient of L times the gradient of A to C, this would be equals to -1. They are negative reciprocal. We know that the tangent is perpendicular to the diameter or the radius of a circle. Then we can say that it is tangent, right? Okay, so we know that the gradient of the line L is minus 2 by 3 times what is the gradient of the line AC. Okay, so we have the coordinates A and C. Let me find for A and C. y2 minus y1, which is 11 minus 5 over 5 minus 1. So this would be equals to minus 2 by 3 times 11 minus 5 would be 6 over 4, right? Okay, so this is minus 2 by 3 times 3 by 2. This would be -1. Okay, so it is proved that the line L is tangent to the circle at point A. Yes. Now moving to part B, find the equation of other circle of radius square root of 52 for which L is also tangent at point A. Right, so we have to find the radius of the circle stays the same. We just have to find the center of the circle. The center is switched now. Okay, the radius of both circle is same. It means the size for both circle is same, right? If this is the first circle with the center C and A is the point lying over here, this is a second circle with the center B, right? Okay, and this line is tangent to the circle. We already know from the first A part, right? Now we have to find another circle. Basically we have to find what is the point B. Okay, so as we know that the radius is same, so the distance from C to A and from A to B, this is same, right? So we can say that the distance of C to A and then A to B, this distance is same, right? Okay, so what is CA? C to A should be equals to A to B because they have the same radius. Okay, CA, if we use the concept of vectors, which is OA minus OC, OA is 1 5 minus OC is 5 11, which is 1 minus 5 is minus 4, 5 minus 11 is minus 6, right? Now using the other concept, what is AB? AB is OB minus OA. We have to find OB. So AB plus OA, this would be equals to OB, right? AB is same as the CA, where they have a same radius, plus AB is OA is 1 5. This is OB, right? Let me simplify. Minus 3, minus 4 minus 1 makes minus 3, and from 6 take away, minus 6 take away, minus 6 plus 5 is minus 1. This is OB. So this would be the center of the other circle. So we can say the equation of other circle with the same radius is x plus 3 whole square plus y plus 1 whole square, which is equals to square root of 52 or just 52. Yes. Question number 8. The first, second, and third term of an arithmetic progression are A, 3 by 2A, and B respectively. For arithmetic progression, we have A n, this would be equals to A plus n minus 1 into D, right? So we have given A, we have given A plus D, which is equals to 3 by 2A, and we have given A plus 2D, which is equals to B, right? The first term is A. So let me solve for D. So what is the D value from here? So the common difference or the D value is 3 by 2A and minus A. So 3 by 2 minus 1 is equals to 1 by 2. A is the D value in terms of A, right? Where A and B are positive constants, both are positive. We need to take them positive. The first, second, and the third term of geometric progression. The geometric progression is A n, this would be equals to A into R power n minus 1, R A 18 and B plus 3 respectively. Okay, so for geometric progression, we can say the first term is A, the second term AR is equals to 18. The third term AR square is equals to B plus 3. Right. So from here we can easily find the common ratio, the R value. The common ratio, the R is 18 over A. In terms of A, the R value is 18 over A. Right. Okay. Now for part A, find the values of A and B, and both should be positive constants, right? So if we consider this A, D, and B, so we can write down D in terms of A, right? So what is this equation? The first equation we can say. So we have A plus 2 times of D, which is A by 2. This would be equals to B, right? We can cancel the 2 with 2. So 2A would be equals to B. This is my first equation. And if we consider this one, substituting R over here, so we have A, R square is 18 over A whole square equals to B plus 3. So what is 18 square? 324. So 324. So this is A square, this is 1 over A. A is cancelled with the square, so over A, this would be equals to B plus 3, right? Take this as my equation number 2, right? So substitute that B value over here, which is equals to 2A, and solve for A. So the two equations were 2A equals to B and 324 over A equals to B plus 3. So 324 over A equals to 2A plus 3. So multiplying by A on both sides, we have 324 equals to 2 times A square plus 3 times of A. So rearrange the equation. 2A square plus 3A minus 324 equals to 0, right? Now let me factorize this. Okay, so we can say that 2 times minus 324 is minus 648. Okay, so if I can take 24 times 27, which is 648, and 27 minus 24 is 3. So 2a square plus 27a minus 24a minus 324 is equals to 0. Okay, so let me take a common. We are left with 2a plus 27, and taking negative of 12 common. 12 times 2 is 24a, and plus 27, because 12 times 27 is 324. Okay, two factors are 2a plus 27, and we have a minus 12. This would be equals to 0. Let me solve for 2a values. So we have from here 2a plus 27 equals to 0. So the a value is negative of 27 divided by 2, and a minus 12 equals to 0. So the a value is equals to 12. As we know that a and b both are positive constants, so we have to consider the positive one, which is equals to 12. Right, so when a value is 12, just substitute into the first equation. We can solve for b. So from here the b would be equals to 2 times of a. So b would be equals to 2 times of 12. So b value is equals to 24, the positive constant. Yes. Now for part B, find the sum of first 20 terms of arithmetic progression. Right, we need to find S20. Sn is equals to n by 2 into 2a plus n minus 1 into d, right? So n is 20, so S20, this would be equals to 20 divided by 2, and 2 times of a value we got from the first part, which is 12, plus 20 minus 1 times the d value. D value is half of a we got from the first part, a by 2. So a is 12, 12 by 2, which is equals to 6, times by 6. Okay, so S20, this was equals to 10, 24. 2 times 12 is 24, and 19 times of 6 is 114, plus 24, and then times by 10, which is 1380. So sum of first 20 terms of arithmetic progression is 1380. Question number 9. The diagram shows the part of the curve with equation y squared equals to x minus 2, this curve, and the lines x equals to 5 and y equals to 1. The shaded region enclosed by the curve and the lines is rotated about 360 degree through 360 degree about the x-axis. So this section is rotated, right? Find the volume obtained. So when we have a rotation through 360 degree about x-axis, we have the formula for the volume, which is equals to pi integration from a to b y square dx, right? But the rotation is the rotation of the whole section. Okay, first let me find what is the point over here from a to b. We have y square, which is x minus 2. So what is the point AB? Okay, okay, so first let me find the point. So at y is equals to 1. So as you can see here, the y is 1. What is x? So we have to substitute here. Y square is plus 2. This would be equals to x. So 1 square plus 2, this is x, which is equals to 3. So x is 3 over here, right? So the points are between 3 to 5, and y square, which is x minus 2 with respect to dx, times by pi, we will get the volume, right? But we just the shaded region is rotated, not this section. This section is not rotated. So this section, as you can see, this is a rectangle, and so basically we have to find the volume of this portion and the volume of the whole portion, right? pi from 3 to 5 y square dx, and then subtract the volume of this portion, right? So we have a rectangle. So if I rotate the rectangle about x-axis, rectangle is rotated about x-axis, we will get a cylinder, right? And the cylinder having the radius, this is the radius of a cylinder, which would be equals to 1, and this is going to be the height of a cylinder, which is 5 minus 3, which is equals to 2, right? Okay, so let me obtain the volume. So the volume is going to be volume of rotation about x-axis minus volume of a cylinder. This is the complete the volume for this one, because this portion is not shaded. We have to find for the shaded region, right? Okay, so let's work on it. So v would be equals to pi from a to b. A is 3 and b is 5. We have x minus 2 dx, and minus volume of a cylinder is pi r square h, right? So we have v would be equals to pi, here we have x square over 2 minus 2x from 3 to 5 minus pi, radius of a cylinder is 1 and the height of a cylinder is 2, right? Okay, so volume is going to be pi, upper limit is 5 square over 2 minus 2 times 5, subtract pi, the lower limit is 3 square over 2 minus 2 times of 3 and minus 2 pi, right? Simplify this further, volume would be equals to pi 25 over 2 minus 2 times 5 is 10 minus pi 9 by 2 minus 6 minus 2 pi. Okay, so volume is going to be, what is 25 over 2 subtract 10 is 5 by 2 pi, and 9 by 2 minus 6 is minus 3 by 2, and then we have plus 3 by 2 pi, and then minus 2 pi. Okay, so we have 5 by 2 and 3 by 2, which is 5. So v would be equals to 5 plus 3 would be 8 pi over 2 minus 2 pi. So volume is 4 pi minus 2 pi. So the volume obtained is 2 pi unit cube. Question number 10, part A, prove the identity. Let me start from the left hand side, doing the cross multiplication. We have 1 plus sine x times with 1 plus sine x, so 1 plus sine x whole square minus 1 minus sine x into 1 minus sine x, 1 minus sine x whole square divides 1 plus sine x into 1 minus sine x, right? So let me open the square. 1 plus sine square x plus 2 sine x minus 1 plus sine square x minus 2 sine x. This whole thing divides with a plus b into a minus b. So we have a square minus b square, 1 square minus sine square, 1 minus sine square x, right? So open the bracket, 1 plus sine square x minus 2 sine plus 2 sine x minus 1 minus sine square x plus 2 sine x, right? This whole thing divides with 1 minus sine square x. We know that cos square x plus sine square x is 1, and 1 minus sine square x is cos square x, right? So 1 minus 1 sine square x minus sine square x. This is cancel out. We are left with 2 plus 2 makes 4 sine x over cos square x. right? But we have to make 4 tan x over cos x. So what we have to do, so we have to divide the numerator and the denominator by cos, right? So we have 4 sin x over cos x over cos square x over cos x, right? So cos and this cos is cancelled, and sine over cos is tangent x. So this is equals to 4 tan x over cos x. This is my right hand side. It's proved. Now for part B, hence solve the equation. This would be equals to a tan x for x lies between 0 to pi by 2. So this whole thing equals to 4 tan x over cos x. We know that from part A. This would be equals to 8 tan x, right? So we can say that 4 times 2 is 8 and tan is cancelled with tan. So 1 by cos is equals to 2. So 1 over cos x is equals to 2, or we can say that cos x is equals to 1 by 2. Okay, so when cos x is 1 by 2, what is x? X would be equals to cos inverse of 1 by 2. It should be in radians, right? Okay, it's in radians, cos inverse 1 by 2, which is equals to pi by 3, right? So the x value is pi by 3, right? And we know that cos is positive in first and fourth quadrant, so we are just dealing with the first quadrant, not the fourth one. So the only value of x which satisfies this equation is pi by 3. And okay, so here I did the mistake. We are not cancelling the tan, and with tan we can cancel 4 and 4. So we have tan would be equals to 2 times of tan x cos x. Okay, so taking tan x common, we are left with 1 minus 2 cos x. This would be equals to 0. So we have two roots. Tan x would be equals to 0, and 1 minus 2 cos x equals to 0 give me cos x equals to 1 by 2, which we already solved. So let me solve for x, which is tan inverse of 0. In terms of radians, we have to do tan inverse of 0, which is equals to 0. So x would be equals to 0, which belongs to the domain, and tangent is positive in the third quadrant. We are not dealing with the third. We are just between 0 to pi by 2, 0 to 90. So we can say we have two solutions. Which is x equals to 0 and pi by 3. I hope this is clear now. Question number 11. The gradient of a curve is given by dy by dx equals to this, where k is a constant. The curve has a stationary point at 2 and minus 3.5. Part A, find the value of k. So we have given the information about this stationary point. For stationary point, we know that the gradient of the curve should be equals to 0. Right at this point. So we can say 6 into 3x minus 5 whole cube minus kx square. This would be equals to 0 at x is equals to 2. Wait, at x is equals to 2, we have 6. 3 times 2 is 6 minus 5 whole cube minus k, and 2 square is 4. This would be equals to 0. Okay, so 6 minus 5 is 1. 1 cube is 1. So we have 6 minus 4k. This is equals to 0. So what is k? K would be equals to 6 over 4, which is equals to 3 by 2. Right. Now for part B, find the equation of curve. So for equation of curve, we have to integrate on both sides. We have dy over dx with respect to dx. 6 is outside, integration of 3x minus 5 whole cube with respect to dx, minus k is 3 by 2. This is outside, integration of x square dx. Right. Let me simplify. Dx is cancelled with the dx derivative, and antiderivative is cancelled. We are left with y. We have 6, 3x minus 5, power is 3 plus 1 over 3 plus 1 times 1 over the derivative is 3. Minus 3 by 2, we have x cube over 3 plus some constant of integration, right? So this 3 is cancelled with this 3. Okay, simplify. Y would be equals to 6 over 4 times 1 over 3 into 3x minus 5 power 4 minus x cube over 2 plus some constant of integration, right? Further simplification, 3 times 1 is 3, 3 times 2 is 6, and 2 times 1 is 2, 2 times 2 would be 4. So y is equals to 3x minus 5 whole power 4 over 2 minus x cube over 2 plus some constant of integration. Okay, how can we solve for the c value? To get the c value, we have to use the condition that we have a stationary point at 2 and minus 3.5. Okay, so for stationary point, we know that let me substitute the y, which is minus 3.5, which is 2 times 3 is 6, 6 minus 5 is 1, 1 by 2 minus 2 cube is 8 over 2 plus the c value, right? Let me solve for c from here. So we have minus 3.5 minus 1 by 2, and we have to do plus 8 by 2, which is 0. So c value is 0. So the equation of curve is y is equals to 1 by 2, 3x minus 5 power 4 minus 1 by 2 x cube. Now for part C, find d2y over dx square. We know that dy over dx is equals to 6 into 3x minus 5 whole cube minus k values 3 by 2 x square. So differentiated one more time, d2y over dx square, this would be equals to 6 times 3, power rule we have to apply, 3 minus 1, and the derivative of the base function is 3, minus 3 by 2 is outside, this is 2x. 2 is cancelled with 2, we are left with 3 times, 6 times 3 times 3, which is 54. 6, 3 and 3, which is 54 times 3x minus 5 whole square minus 3x, right? So let me open this here as well, or you can keep the second derivative as it is. Now for part D, determine the nature of the stationary point at 2 and minus 3.5. So for the nature of the stationary point, we can check for second derivative d2y over dx square at x is equals to 2. If it is positive, we have minimum. If it is negative, we have maximum. So we have 54. 3 times 2 is 6 minus 5 whole square minus 3 times 2, right? So we have 54, and 6 minus 5 is 1, 1 square is just 1, minus 2 times 3, which is equals to 6. Okay, so from 54 take away 6, we have 48, which is greater than 0. So when the second derivative at the stationary point is greater than 0, we have a minimum. Nature is minimum. Question number 12. The diagram shows a cross section of 7 cylindrical pipes, 1, 2, 3, 4, 5, 6, 7, each of radius 20 centimeters. So the radius of all the cylindrical pipes are 20 centimeters, held together by a thin rope which is wrapped tightly around the pipe. This is a thin rope. The center of the 6 outer pipes are A, B, C, D, E and F. So 6 outer pipes we have given the center. Points P and Q are situated where straight sections of rope meet the pipe with center A, P and Q. Okay. Now for part A, show that the angle PAQ, this angle we have to find. This should be pi by 3 radians. Okay. So if we can see, if we consider this a circle and A to Q is a radius and A to P is the radius. So if I extend this line the tangent to the circle at point Q and tangent to the circle at point P. And we know that the tangent is always perpendicular to the radius. So if this line is tangent at Q, so it is perpendicular to the radius, and the tangent at P is perpendicular to the radius, right? Now we have to find, okay, and what is this angle? Okay, now let's measure this angle first. So as we know that this side has 1, 2, 3, 4, 5, 6. So this shape has 6 sides. So this shape is a hexagon, and we know that measure of each interior angle of hexagon is number of sides minus 2 times by 180 divides the number of sides. Okay, so there are 6 sides. 6 minus 2 times 180 divides 6. Okay, now let me simplify this. 6 minus 2 is 4. 4 times 180 divided by 6, which is 120. So this is 120. And in terms of radians, we have to multiply this by pi by 180, dividing by 180. So this is 2 by 3 pi. Okay, so we got this angle 2 by 3 pi. We have to find this, and the two angles are 90 degree, right? So if we consider this quadrilateral P, A, Q, and let's say this is O, right? We know that opposite angles of a quadrilateral sum up to 180. Or if we consider this shape as a kite, so we can we know that the sum of all angles of the kite is 360 degree. So we can say that you can use both concepts, right? So if I use the concept, the opposite angle of a quadrilateral sum up to 180, opposite angles are angle 2 pi over 3 plus PAQ. This should be equals to 180, which is pi by pi is 180. Yes. Now let me find PAQ, which is equals to pi minus 2 by 3 pi. Okay, we can say 1 minus 2 by 3, which is 1 by 3 pi. So it is proved, right? Now moving to part B, find the length of the rope. Now let's work on the length of the rope. Okay, so if you can see, this is A to Q and B to some point, right? So what is this length? We know that B to this is 20 centimeter, this is 20 centimeter, so this is 40 centimeter, right? Same, we have to do this straight length is also 40 centimeter. This straight length is 40, 40, 40 and 40 centimeter, right? Now we need to find this curved one. What is this curved length? Like if you can measure this curved length by, if I can say, for arc length, basically this is the arc length we have to measure, right? So we can say that each straight length is 40 centimeter, right? And each curved length is basically the arc length, that is radius times theta. So what is the radius? Radius we know is 40, and theta we have 2 pi, pi by 3, right? Sorry, the radius is 20 centimeter we have given, not 40. So the radius is 20 times pi by 3. Okay, so this is 20 pi over 3, right? So now we have the length, or to find the total length of the rope, we have to sum up the straight edge, the straight one, right? And the curved one. So how many straights? 1, 2, 3, 4, 5, 6. And how many curved? 1, 2, 3, 4, 5, and 6 curved, right? Okay, so now let me find the total length of the rope. Right, this is equals to 6 times of straight edge plus 6 times of 20 pi over 3. This is the total length. Let me calculate. 6 times 40, which is 240, plus 6 times 20 over 3, which is 40 pi, right? 40 times by pi, okay, 40 pi plus 240, this is equals to 365.6, or we can say that 366 centimeter. This is the total length of the rope. Now for part C, find the area of hexagon A, B, C, D, E, F, giving your answer in terms of square root of 3, right? Okay, let me draw this hexagon. You can connect the point A, B, B to C, and then D, and then E, F, and again A. You have to find area of this hexagon, right? Let me break this into triangles. If let's say this is a center O, let me connect A with O, B, O, C and F, E and D. Okay, so basically we have to find the area of one triangle. We have 1, 2, 3, 4, 5, 6, and times by 6 we will get the area of the hexagon A, B, C, D, E, F. Okay, so as we know that A to this is 20, and this the radius of all the cylindrical pipes, all the circles are 20. So 20 plus 20, this side is 40, this side is 40, and the interior angle is pi by 3. It's a regular hexagon. We know that this angle is pi by 3, so this is also pi by 3, right? So let me find the area of the triangle AOB. So we can say that area of triangle AOB, which is half the two sides, which is 40 times 40, and sine of the angle between them, which is pi by 3, right? Let me calculate. We have sine pi by 3 times 40 divided by 2. Okay, we have to convert, keep our answer in terms of square root of 3, right? Okay, so sine pi by 3. Okay, 40 times 40 divided by 2 times square root of 3 divided by 2. Okay, so we have 40 times 40 divided by 4, which is 400, square root of 3. We have to keep it in square root of 3, right? So now we can say that area of hexagon, this is 6 identical triangles, so we have 6 times 400 square root of 3. 6 times 4 is 24, so 2400 square root of 3 centimeter square is the area of the hexagon, right? Now for part D, find the area of the complete region enclosed by the rope. Okay, the area of the complete region. So we have the area of this hexagon. We have to find the area of this outer one. So if we can connect A, okay, it's a rectangle. right? And this and this a rectangle. Okay, now let's observe this closely. So we have the area of this hexagon, which is 2400 square root of 3. We have to find the outer one to complete the area of the, to find the complete complete region enclosed by the rope, area for the complete region, right? So as you can see, this is a rectangle, a rectangle, 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 and a rectangle. 1 2 3 4 5 6. We have 6 rectangles, right? So this is 40 and this is 20. So first we need to find the area of rectangles. Area of rectangles. There are 6 rectangles. Length is 40 and the width is 20. Right. So 6 times 40 times 20, which is 4800 centimeter square. Right. Now the next thing is we have to find what is the area for this curved section, right? So this is basically the arc length we have to calculate, right? Area of each sector, right? We can say area of each sector. So again, there are 6 sectors. Area of a sector formula is half radius square theta. So we can do 6 by 2. Radius we have for all of them, the radius is 20 square and the theta is pi by 3. We got the theta from the first part, which is pi by 3, right? Let me calculate this. So we have 20 square times 6 divided by 2 times by pi by 3, which is 400 pi, right? Now let me find the area of the complete region enclosed by the rope. So the complete area is basically made up of area of this hexagon plus the 6 rectangles and 6 sectors, right? Okay, so area of a hexagon is 2400 square root of 3 plus 4800 plus 400 pi, right? Let me calculate this. 2400 square root of 3 plus 4800 plus 400 pi, which is 10,213.5. We can say 10213.6 centimeter square. This is a complete area. Let me round this to 3 significant figure, which is 10,200 centimeter square, right? So that is a complete area for the region enclosed by the rope. So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.